Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. Thank you so much for tuning in. I hope that you're having a fantastic Friday and you are ready for the program. Because today on the show, you may have guessed, Ralph Bond. I know. No one saw it coming. But we have Ralph Bond on, and with a crazy week, I can only be sure of, well, everyone, let's relax. Let's have a nice, fun, upbeat show here with Ralph Bond. He is our science and tech trends correspondent, and we are going to talk about things that, you probably haven't heard of before because, there's only so many places that you can really go to hear everything from material sciences to automation to physics to supercomputers. Ladies and gentlemen, these shows are very, very diverse, I will say, which is always fun, but they're also kind of niche, which means that you probably haven't heard them in the main channels that most of us watch news. So with that being said, computeramerica.com, definitely not one of the main channels, but if you go there, you'll find all of our past shows, all of our recent shows, and everything that we do here, including the show notes, which make it very simple to go through, fact check us, make sure that we're not just making stuff up, because some of the stuff seems so unbelievable that I wouldn't be offended if you're like, no way that's a thing. computeramerica.com. So with all that being said, let's go ahead, bring Ralph on and just have fun with it. Ralph, welcome back onto Computer America. How you been?
I'm doing great, and it's always great to be back. And again, as Ben was saying, please, if you're listening to us as a podcast, come out to computeramerica.com because we will have pictures, links, and the notes from our show today, what we're going to do. And again, if you're new, welcome. What we do every Friday, Ben and I look at 4 articles that show us key trends and developments in all kinds of things in science and tech, including, of course, without question, artificial intelligence. That's everywhere. But robotics, medical technology, sustainable energy technology, transportation advances, agricultural tech, construction tech, space research, physics, on and on and on. Most important of all, we're going to give you hope for a better future, thanks to amazing breakthroughs happening every single day in the world of science and technology.
Absolutely. And we're going to start with number 1. I will do a quick translation for our friends over in the UK. Aluminum will be pronounced aluminum and not aluminium for this segment. So, but it is the same thing. So, yeah, Ralph, let's talk about aluminium.
And I also like the way innovative is innovative. It's fun. The British versus American English is a hoot. But the headline here comes from ScienceDaily.com. MIT, of course, Massachusetts Institute of Technology, just made aluminum 5 times stronger with 3D printing. Subhead, it's stronger, lighter, and tough enough to reshape the future of, for example, flight, right? Where aluminum is used extensively in aircraft bodies and so on. And of course, in the show notes, we have a link to the original article and other supplemental links as well. So please come out to the show notes. Now, here we go. MIT engineers created a new 3D printable aluminum alloy that is 5 times stronger than standard cast aluminum. 5 times stronger. The alloy also stays stable at extreme temperatures up to 400 degrees Celsius. That's about 752 degrees Fahrenheit, which is unusually high for aluminum. If you've ever taken, when I was a kid, we would take a pop can, an aluminum soda pop can, and throw it into a campfire and, get to see it melt and all that sort of stuff, and probably exposed ourselves to toxic fumes. But anyway, the ability to withstand up to 752 degrees Fahrenheit is significant. So how did they do this? Instead of, you're going to like this, Ben. This is where artificial intelligence comes in. Instead of testing over 1 million possible alloy combinations, researchers used machine learning, aka artificial intelligence, to narrow the search down to 40 candidate solutions. wow. And the
That
winning
is,
formula, yeah.
and that's just so cool. It's not, completely removing the need for humans. It's just removing the need for a million humans and maybe making a small team capable of, testing the best of the best. It's so cool.
And it's great. And the fact that artificial intelligence, the large language learning model they used, came up with 40, not just one, but 40 possible ways to go. And the winning formula produces nanometer scale precipitates, which are tiny internal structures that dramatically increase strength. And I went, and precipitates? Oh, what's that? Well, that's what I do in the show notes. I went out and said, please tell me what a precipitate is. Well, it's what you get when two liquids react and make a solid that wasn't there before. The solid often looks cloudy, grainy, or settles to the bottom of a container. So that's a good example of what we do with the show notes. I also insert things when I don't understand something. And believe me, most of this is I don't understand. But certain words, the definitions that the authors of these articles assume you know, I'll insert into the show notes. Another reason, please, to come out to the show and get those notes. So 3D printing using laser powder bed fusion cools the metal extremely fast, preserving these ultrafine structures, the precipitates that traditional casting would destroy. And again, I'm not going to go through reading all of this, but in the show notes, I thought to myself, okay, laser powder bed fusion. They assume I know what that is. I don't. So I've inserted that into the show notes. You can learn all about that. We're not going to take time to do that. But let's talk about why this breakthrough matters. The alloy could replace heavier, more expensive metals like titanium in jet engine fan blades, high-end automotive parts, vacuum pumps, data center cooling systems. So again, the point, people, if you have an aluminum that's 5 times stronger than traditional aluminum, it could have a role in things like jet engine fan blades, replacing titanium, for example. So this is very potentially significant stuff. Lighter, stronger parts means major energy savings in transportation and in industry as overall. And to wrap things up here, this is a materials science milestone. Machine learning plus 3D printing equals alloys that were previously impossible to design or manufacture. And MIT expects this approach to reshape how high-performance metals are engineered. Wow.
It makes a lot of sense that you would choose something like titanium or steel or whatever because of the added strength that it provides. But hey, Ralph, if this aluminum has that same benefit, is cheaper hopefully to make, and can have all the efficiency. It's not like we don't have plenty of uses for titanium and other things, but the more you can replace it with cheaper, easier to produce, hopefully, and more efficient metals, hey, just the better everything gets. It has a cascade effect that improves a lot. So
very significant. And just another example of every single week in MIT and the team there are doing just amazing stuff.
Definitely worth the investment in. So there you go. Story number 1. Who knew to make aluminum even stronger? So story number 1, story number 2, we're going to go ahead and jump over to this one. This one is a little bit about quantum computers, so don't freak out. Don't get scared. Ralph's going to explain it to you because I sure can't. But there's this idea, Ralph, that quantum computers, supercomputers, they do these tasks and these computations that traditional computers really couldn't handle. But these problems are problems that I think everyone wants to solve. It's like, what is the weather going to be in 7 days? That's the kind of stuff that you can do. What are complex systems going to do in the future? And being able to work those out on cheaper, better, faster, easier hardware every day, that's an important trend that we're seeing. Just bringing that cost of scale bringing that cost down to solve these problems. Anyways, long story short, story number 2, let's talk about a physics shortcut, whatever the heck that means.
Yeah. Oh, yeah. And I'll forewarn everybody, this is extremely, extremely geeky. And believe me, I barely can wrap my brain around quantum mechanics and quantum computing and all that sort of stuff. So there's a little personal truth and lending up front here. But this story comes from livescience.com. And here's why this caught my eye. Get a load of this headline. A new physics shortcut lets laptops tackle quantum problems once reserved for supercomputers and artificial intelligence. Now, this is not saying that these, you'll find out, it doesn't mean to say that laptops can replace gigantic computers, but in certain aspects of quantum computing, they can. And we're going to get into this. Let's dive into this. Researchers at the University of Buffalo have developed a new physics-based shortcut that allows ordinary laptops to solve certain, not all, certain quantum physics problems that previously required supercomputers or advanced AI systems. The breakthrough is connected to quantum systems, entanglement, and quantum mechanics, areas that normally demand massive computer computational power.
Of course. Quantum entanglement, of course.
Yeah, my brain just melts right away. The technique dramatically reduces the computational load by using insights from physics rather than brute force calculation. It's so compelling. The article frames this as a major step toward making quantum research more accessible, potentially accelerating progress in quantum technologies. Now, there's an insert or a part of the article that's extremely geeky, but I inserted some information here, a kind of a plain language explanation of the physics shortcut they're talking about. I'm not going to go through all of it, but I'm just going to highlight a couple of bits from it. Let's scroll down here. Here we go. The basic takeaway, you can think of this like being, instead of calculating everything, they identify patterns and constraints built into quantum physics and use those to jump directly to the answer they're seeking. Do I understand this? No. It's similar to solving a maze by knowing the layout rules instead of exploring every path. Think about that for a minute. It's similar to solving a maze by knowing the layout rules instead of exploring every path. So you think about artificial intelligence, say, what if, if then else, all constantly looking at as if you're in a maze going, well, if I turn this way, what happens? If I turn that way, if I go straight, what happens? If I go backwards, No, they're saying it's similar to solving a maze, knowing the layout rules instead of exploring every path. This is the shortcut they're talking about. And of course, this dramatically reduces the computational load. And why can a laptop do this that normally a supercomputer would? Well, because the shortcut avoids the exponential explosion of calculations. A regular laptop can now solve certain quantum problems that used to be out of reach. And it's not that laptops suddenly got more powerful. No, it's that the math got smarter. Okay, if you're an intelligent genius person out there, go and read this article. You'll probably understand it more fully than I do, but wow, a pretty interesting development.
For sure. I've even, I'm sorry that I bring this up so often, but I have talked to the head quantum researcher over at IBM before. It still goes over my head completely. Even the smartest people can explain it to the lamest of men, myself. And there you go. Can't even wrap your head around it. But what I do pick up from it, Ralph, and this is something that when it comes to quantum research, you have these issues where some people create problems for quantum computers that a traditional computer can't solve because you need the architecture that quantum computers have. But if you just simply reframe the question to work on traditional hardware a little bit better, you can actually get, traditional computers to solve these problems. I wonder sometimes how much of these are the way that the researchers are asking the questions versus the way that the hardware is built. This seems like one of those things where they gave the qualifier at the end for certain problems.
Yes,
we can switch this to a different architecture, which is good.
Exactly
offloading that to traditional hardware, very good to free up, quantum computer. But this won't solve everything. This does not negate the need for quantum computers. Just switches the workload a little bit, and it's again cool that math involved. Something that is just over my head. So there you go.
Yeah, and the whole world of quantum mechanics and so forth is so bizarre. And friends, if you really want your brain to melt and drain out your ears, learn about something called superposition, and that's where a qubit can be both positive and negative at the same time. What?
Yep.
And to illustrate this, I do an exercise with my 4.5-year-old grandson, and I say, "Hey, Cal, I'm me, you're you." And Cal goes, "No, I'm me, you're you. No, I'm me." We go back and forth. Then I said, "Wait a minute. Guess what, Cal? We're both me and you at the same time, if you think about it." And I tell him, "Tell your mom and dad that's superposition."
Not far from the truth. Absolutely. It's a very weird world when you get to quantum.
Extremely weird.
Yep. But we're going to leave that behind in story number 2. Story number 3, though, we're going to go ahead and go to something a little bit more understandable. Magnets. Everyone understands magnets. No one here is confused at all about how magnets work. So when we go to China and talk about Chinese magnets, this is going to be super simple for everyone. So Ralph,
sure.
Let's talk about the wonderful futuristic technology that is certainly here, Hyperloop technology.
Yes. So this comes from interestingengineering.com. It's all about magnetic levitation trains. So the headline here, Hyperloop shock. China's Maglev hits 435 miles per hour in 2 seconds, setting, of course, a world record. Wow. Friends, the Chinese are really on top of some technologies that are leaving us in the dust, especially in transportation. But anyway, researchers from the National University of Defense Technology in China, let that think defense technology, okay, have set a new world record for superconducting maglev technology by accelerating a 1.1 ton, test vehicle to 700 kilometers per hour, that's 435 miles per hour, in just 2 seconds on a 400-meter track. Boy, would I love to see that thing happen. That's got to be just stunning.
Well, if the nice folks are watching the video portion, they can see, they kind of did the experiment there, and the video does actually show it, kind of getting up to speed and setting the record. It's right there.
It's a blur.
So,
and that's something that really is so fast. It's a blur. It's just, and the fact that it's their military is kind of interesting. Makes you go, okay.
Yeah, they have a quick little still frame for, just to jump ahead a little bit in the story, but they show this image here of, you can imagine, I think everyone's seen like warships and the aircraft carriers, and they have the catapults that launch the
catapults, right?
Yeah, the catapults. Same thing. I don't think they're going to go from 0 to 400 miles an hour because that might kill someone. But for maybe drones or something, I could imagine launching drones very, very quickly on a very short runway and things like that. So
yeah. So it is interesting. It's their military that's looking at this. But hey, by the way, folks, a reminder: maglev is short for magnetic levitation, a transportation technology where vehicles, particularly trains, float above a guideway using magnetic forces instead of wheels. So there's no contact, which I think is fascinating. So going back to the story, the system also demonstrated precise, rapid braking, marking a major leap in ultra-high-speed electromagnetic propulsion. This breakthrough solves several long-standing challenges, including ultra-high-speed electromagnetic propulsion, stable electric suspension and guidance, high-power energy storage and conversion, control of high-field superconducting magnets. So those are some of the things this research has solved. Now, beyond trains, the article talks about other broader applications for this same technology. This fits perfectly with what you were just saying about launching aircraft, that sort of thing. Provide ground-based launch assistance for rockets or aircraft, reduce fuel use during takeoff, interesting, enable Hyperloop-style vacuum tube transport, something akin to that, and support aerospace testing. This is really interesting. Support aerospace testing by simulating extreme speeds without flight.
I guess if you need to test something like wing flutter, I guess that could be something. That
there you go.
That you could do. But no, it makes a lot of sense why the Chinese Defense Department would look into this technology. I'm sure that their American counterparts are also looking into it. But then the emphasis that maybe this technology could also go like you said, beyond trains, but also trains and other consumer friendly applications. Yeah, I think a lot of people would go. I don't know how much train goers would love accelerating from 0 to 400 miles an hour, but the use cases for it are pretty wide, and hopefully hopefully someone finds a use for Hyperloop, because Ralph, I think just last year or the year before, they like officially decommissioned and like completely scrapped everything that was Hyperloop from California. You know, like they just said that whole thing is just never going to happen. So
Right.
the technology is cool. It's there. Everyone has access to the research. It's just who can kind of bring it out to market and do something innovative with it. Yeah, that's remains to be seen. So cool video. You can check it out there in the show notes.
Yeah.
It's in this article. It's pretty fascinating. And I don't know, Ralph, maybe it's just the American in me. I'm like, when any other country's military does anything, I'm like, I don't like that. But maybe that's just, you know, me being an American.
Oh, I hear you. You know, the ultimate fantasy I have in my brain, I'll never see it, I'm sure. Can you imagine a world where instead of being adversaries, the geniuses in Russia, the geniuses in China, and our own geniuses here and elsewhere too, of course, Europe and so forth, what if we all worked together? What if we stopped this stupid adversarial junk and came together to help humans? It's sort of like John Lennon's song Imagine. I digress.
No, in every week in a lot of these stories, you do highlight that, you know, you do have research facilities in Taiwan, in Australia, in America, and the UK, and Germany, and South America, blah blah blah. There is that collaboration. It is there, and
there are some wonderful cases of collaboration with the U.S. based and European based, collaborating with Chinese researchers. It can happen if we just let scientists run the world. I think we'd be in a better place. But that's my personal opinion.
There you go. So with that pie in the sky attitude, let's go ahead and go to story number 4. And you know, this is one that's also another trend. Just really the amount of progress, I think, Ralph, I would say like 3 years ago, if you asked me what like the blood-brain barrier was, I'd be like, who the heck knows? And something with the brain, I guess. But in the past 3 years, we have seen so much research and so much to do with like getting to the brain, working with the brain, doing it in so many different ways, invasively, non-invasively, robotically, autonomously. There's so much research into brain health that this story number 4 continues on with it, and it's also very cool.
You're so right to frame this and to explain that it has to do with treating the human brain. And folks, if you're new to the show, what we usually do with the last of the 4 stories we highlight each week, it's usually in the field of medical technology, and this, of course, is. And this comes from the Washington University Taylor Family Department of Neurosurgery. Excuse me. And the headline here is Nasal Drops Fight Brain Tumors Non-Invasively. Nasal drops. Nano-sized medicine boosts anti-cancer immune response, eradicates tumors in mice. This is early research. Once again, thank you, mice and rats and pigs, for your contribution. But let's get into this story. Excuse me. Glioblastoma tumors form from brain cells called astrocytes and are the most common kind of brain cancer, affecting roughly 3 in 100,000 people in the United States, for example. And glioblastoma is an aggressive, fast-growing cancer of the brain or spinal cord, and it begins in astrocytes, which are star-shaped support cells that help nerve cells function. And glioblastoma generally progresses very quickly and is almost always fatal. There are no curative treatments for the disease, in part because delivering medicines to the brain remains extremely challenging. And that's where that blood-brain barrier comes into play. Now, researchers at Washington University School of Medicine in St. Louis, along with collaborators at Northwestern University, have developed a non-invasive approach to treat one of the most aggressive and deadly brain cancers. Their technology uses precisely engineered structures assembled from nano-sized materials to deliver potent tumor-fighting medicine to the brain through nasal drops. What?
That is about as non-invasive as you can get with the treatment, especially with the brain.
It's just so great. And the novel delivery method is less invasive than similar treatments in development and was shown in mice to effectively treat glioblastoma by boosting the brain's immune response. Now, how does it work? The medicine rides a nerve highway that directly connects the inside of the nose to the brain. Who knew? I didn't.
So you can tickle your brain when you shove a pencil up your nose. I knew it. Second grade me knew it.
But don't do it. Okay, so here's how it works step by step. Okay, step one, the drops, nanomedicine, are placed inside the nasal passages. The particles in the nasal drops, step two, the particles in the nasal drops latch onto a major nerve that runs from the face to the brain. And you can learn more about that in the show notes if you want to get more details there. Step three, the nanoparticles move along the nerve fibers and can bypass the blood-brain barrier. Bypass the blood-brain barrier, which normally blocks most drugs. And I've got a little optional insert, a reminder of what the blood-brain barrier is in the show notes if you want to get into that. But let's keep going. Step four, after traveling along that nerve, the nanoparticles reach the brain tissue, including the glioblastoma tumor, and step five, once inside the brain, the drug triggers an immune attack on the tumor. Ben, I rest my case. If you need to be uplifted and given hope about the future, thanks to science and technology, and in medicine particularly, this story is so wonderful.
still very early research, still working on animals, but could you imagine, one of the most common, and luckily 3 in 100,000 is very, very low, but for those who do get it, imagining your treatment just being, okay, you have this, we're going to start you out 6 months, take your nasal drops and your brain cancer will go away. That's the future, that
it's
could
amazing.
conceivably
Wonderful.
be in our sights. So very amazing. Story number 4, always love medical technology. It is really one of the best fields out there when it comes to technology and what it can do for people. So,
absolutely.
Now, with that being said, if you're following along in the show notes, because by the time that you hear this, you can, of course, see it up on our site, you may notice there are still half the show notes to go. And you're like, but wait, you guys are wrapping up. Well, that's because we try to keep our show a bit more concise, and that's just for you. But for everyone else out there that wants more, Ralph always delivers more, and that's in the honorable mentions. These are stories that are just as good, just as compelling. In all reality, Ralph, if we were still doing a 2-hour show, we would be doing these stories. But for everyone out there, come out to computeramerica.com, check out the show notes, and we're going to give you the headlines, but you can find the links, find more about these stories, and you should definitely hear about them. They're all great. So, Ralph, the headlines.
Yeah, we have 4 honorable mentions. That's our usual pattern. First one comes from CNN. Headline, this 3D printed carbon absorbing bridge is inspired by bones. And you've got to see a picture of this thing. It's so weird looking, but it's very, very cool. Check that out.
Like something out of a video game for sure.
It does. And it's a good example of exciting technology in the world of construction. Just an amazing thing. Next one, sciencealert.com is the source. Headline, new drug stalls Alzheimer's development in breakthrough trial. There's so much research, of course, trying to battle Alzheimer's. That's a good one. Next one comes from phys.org. Scientists build a quantum computer that can repair itself using recycled atoms. Okay, if you want your brain to melt.
Because I would never be able to fix one if it broke. I can barely fix my standard computer. I can't imagine trying to fix a quantum computer.
Yeah, that can repair itself using recycled atoms. That alone, what the heck is recycled atoms? Well, come out and check it out. You'll find out. Next one here, I think this is our last one, from University of Connecticut. Headline, new image sensor breaks optical limits. And I inserted my own little personal subhead to this. It's a lens-free system that achieves submicron 3D resolution across a wide field of view, something previously considered impossible with optical wavelengths. Another melt your brain geeky thing, but very, very interesting stuff.
I'm sure it will be available on the next Samsung phone, and instead of 100 times zoom, you're going to get like 1,000 times zoom, and you're going to be able to just record your cells or something. There you go. So very, very cool. Ralph, thank you for all these stories. They're all great. And ladies and gentlemen, if you want to find out more, or if you want to fact check, or if you want to just make sure that we're not just making these up, check it out. No hallucinations here. All real stories. And Ralph, thank you for highlighting these. This is always the best way to head into the weekend with something fun, upbeat, positive. And ladies and gentlemen, I hope that you do have a great weekend. Thank you for joining us here on Computer America. As always, thank you to our science and tech trends correspondent, Ralph. And until next time, everyone, have a great day. Thank you so much. We'll catch you next time. Bye, everyone.